Hello, this is Rick Harnish. I'm the Executive Director of the Midwest High-Speed Rail Association. Thank you very much for joining us today for this week's Brown Bag Lunch, where we'll focus on Stadler train design. I want to give a quick overview of who we are and what we're about, and then we'll switch to the main program. So we are a nonprofit, for those who aren't familiar with us. We're a nonprofit educational organization focused primarily on education. We're supported by individual member contributions for the most part. We have 3 program areas. We strive to be the most knowledgeable, independent source of what high-speed rail is, why we should be building it here in North America, and what steps local leaders can take to do that. We educate the public and local leaders through multiple forums, this being one. Another is that we have been able, in these interesting times, to do 1 or 2 Rotary Club presentations a day. And I've been doing those all around the country. So if you would like us to set up a Rotary presentation, please let us know. And then the third is we provide people at the local level the tools they need to then organize or educate their leaders in state capitals and Washington in order to actually start getting the process moving forward. So we believe in the integrated network approach, where instead of looking at city pairs, we believe that states, regions, and the federal government should be looking at networks where pieces are put together kind of like Lego blocks, where you can assemble Lego blocks in different ways depending upon what your objectives are with that day, based on what your local assets are, what the local market is. You can assemble railroads in a multitude of different ways. But to simplify the issue, we've boiled it down to high-speed lines where you're building new electrified high-speed track for trains going faster than 160, regional lines where you are focused on fast passenger trains, perhaps mixed with freight, and then shared use lines where states and are working with existing railroads to run more frequent, more dependable and faster passenger trains. And then the fourth element being intercity buses to fill in the gaps, with sometimes the trains taking a trip all on all 3 types of track in one trip. We are working right now as Congress is debating what the future of the transportation networks looks like and policy looks like over the next 5 to 6 years. Our goals are worked around 3 key principles. 1, we believe that to be successful in gaining political support, it needs to be national in scope. And that's where the integrated network comes in, where most of it is actually working on with freight railroads to run better service. But the high-speed lines bring in that huge tip over the cliff in key areas to bring a lot more volume into the system. We want to be optimistic, believing that we can have a fast-growing system and plan for the big transformative wins like new high-speed lines, start working on them, but also find immediate quick wins that people can move forward with. And then the third is we believe that we need to get to the point where this is a good business proposition for the Class 1 railroads, just like building highways is a good business proposition for highway builders, and building weapons is a good business proposition for defense contractors. We're at a unique opportunity where you've got the Biden administration saying very clearly they want to expand passenger rail and high-speed rail very quickly. We're excited about that. We've got a number of bills out there that will move us in the right direction. Congressman Moulton has introduced a bill that would create a high-speed rail program. The House passed a bill that would vastly expand Amtrak service. And Senator Republican or Representative Costa from California has introduced a bill that would expand the high-speed rail program. So I apologize for getting a little bit too far. I want to introduce our guest. And if you have any questions as you go, please put them in the question and answer box, and we will answer them as they go. And I'd like to introduce Matt Sibul, who is the Director of Sales and Program Development at Stadler, who is has some very innovative train set designs that are currently in operation in North America. And I found out one of them is in the process of being moved to Pueblo for testing. So Matt, if you would like to get started, we're ready to go.
Great, thank you. Hopefully everybody can hear me and perhaps see me. More importantly, I'll share a slide deck with everybody in just a minute here, but super excited to chat with the group and engage with the High Speed Rail Alliance. We love the work, Rick, that you're doing in your organization, and you've got a great audience. And I think with the current administration in Washington, I think there's some great things to come and some great growth opportunities for the industry and really for all of us. So happy to be here. Let me try and share my screen here if I could, and we'll see if we can get technology to work. Let's see here. I go. Are you guys seeing a full set of slides?
Yeah, so you need to hit the
it seems like you're still struggling with the technology, but in the meantime, I joined as well. So hello to everyone.
Oh, hi, Guido. Good, good. Let me tell you what. As Guido teases me, I'm going to try this again. It always works better when I have it on one particular screen here. My apologies. Where did that go? Why can't I get this to work? So let me try this again.
Okay, now we see more people.
Yes, we're up to 74.
Good group here today. So, what are you guys seeing? I'm having an issue with this.
So the normal version.
Okay, let me
click there. Yep.
How's that?
Oh,
perfect. Okay. Thank you. Okay, let's get into this. And I'm glad Guido was able to join us. But these are the things we wanted to be able to cover off today, and maybe even talk a little bit about high and higher speed rail. But we wanted to cover off a few of our products and just evolution of technology. So thanks again. You now see Guido, which is great. I'm glad Guido Vogel is able to join us. He's our head of engineering here at Stadler US, and both Guido and I sit in Salt Lake City. That's where our brand new headquarters are of Stadler US. And I'll talk a little bit more about that, but we just opened up this shop in May of 2019. And there's me, I'm the head of sales for Stadler US. So why don't we just get right into it, and wanted to leave plenty of time to take any questions. Just briefly, for those of you who may know Stadler or a little bit about Stadler, we do have a large portfolio of different trains. The kind of the roots of the company are on the lower left, with kind of tailor-made and very custom train sets, usually made for mountains with rack and pinion and navigating very steep grades. But the company over the course of the last 3 decades has really expanded and gotten into building subway lines, metro lines. You see there in the middle. So these are the number of units that we've delivered over the course of the last 30 years. Light rail, Stadler bought the Vossloh organization in the Valencia area a few years ago. So now we're in the light rail business. And then also you can see kind of the bread and butter are the GTWs on the upper right part of the screen, commuter rail lines, the bi-level KISS product. We'll talk more about that, as well as the FLIRT, the single level train there. And that's the units that we've sold the highest amount of. Stadler does also build a what's called a SMILE, or in Europe it's the EC250 or Giruno. I believe it's labeled by Swiss Federal Railways. And that's a higher speed train that actually goes up to about 160 miles an hour. And so I know this group here has discussed in the past, what is the definition of high speed, and there's higher speed. And I think the industry is probably, there's lots more to be discussed about what is the true definition of high speed. So that's a little bit about the portfolio of the company. As you would expect for a large multinational, so we're located in many different countries across the globe, mostly in Western and Central Europe. The Stadler US facility is technically right now part of Division Switzerland, and so that's why you see us beneath the Bussnang and the Altenrhein shops. But we're across Central Europe and Eastern and Western Europe, and then we have a service division too that has expanded greatly, and we're in about 15 different countries. And so we not only design and build the trains, but we also have a full service maintenance group that cares for them. A little bit about our projects in the US over the past almost 20 years now. So even though we just opened up our new facility in 2019, the company's been delivering trains in the US since 2002, the River Line with the GTWs, those 20 units. And then you can see that the GTWs for Capital Metro and Denton County, eBART, and then again for Capital Metro, those were the last of the GTWs delivered in the US, and now we transitioned more into the FLIRTs, the single level trains. And then in the current kind of era, we're going to talk more about the CalTrain train, the one that Rick, you alluded to. It's on its way to Pueblo, Colorado for type testing. We're happy to see that. It should arrive soon for that. And then you can see some of the other projects I mentioned that we're now designing, and they're going to be soon building metro cars for Atlanta, for MARTA. And then some of the other FLIRTs you see. So for DART, we're going to be building 8 train sets for the Silver Line in Texas, in Dallas. And then for San Bernardino, in addition to 3 DMU FLIRTs that run off diesel, we're going to actually, and we'll talk a little bit more about this, we have a hydrogen fuel cell train that we're going to be delivering to San Bernardino as well. So lots of different things from a propulsion perspective, and I think that'll fold into the conversation nicely. And then maybe just a little bit more about our shop here. So it came together very quickly, just in the matter of about a year and a half. It was designed and built, and so we opened it up late spring of 2019, and you can see it's about 250,000 square feet of production space, and the campus is about 62 acres, so we have plenty of room to grow. And we have assembly areas for all parts of train building, as you would expect, and including trucks, and then final assembly in the hall there. And then we do have a commissioning and test track area. We're actually expanding our commissioning bays by about twice, about double as we speak. And then just a little bit more of the focus across North America, kind of the two, I guess, bread and butter train sets are the FLIRT, the single level on the left. So we delivered those to TexRail and about to deliver them to San Bernardino. We'll start delivery of the DMUs shortly. And then DART, like I mentioned, we took delivery of the car shells. We started to take delivery of those car shells. Those are going to be painted here at our facility in Salt Lake. So we just commissioned and opened a paint booth over the last few months. And then there's the bi-level CalTrain, the one that's en route to Pueblo right now, to TTCI. And then I mentioned the subway cars that Guido's team is currently engineering those right now for our customer at MARTA. And then sort of some of the more unique products that we have delivered. So Rocky Mountaineer, that's a tourist train up in British Columbia. And we are also designing and building the replacement trains for the Pikes Peak, Manitou and Pikes Peak Railway in Colorado Springs, or Manitou Springs, Colorado, which is an incredible train and view. If you've been to the top of Pikes Peak, it's just an absolutely amazing experience to be up there. I've hiked it and then taken the train down, which is also enjoyable. So I wanted to transition a little bit to just sort of the US market and the topic of multiple units and sort of how they fit in, or maybe are transitioning and maybe evolving into the US market. And this, of course, for those on the webinar, this is nothing new in Europe. Europeans have been doing multiple units and for decades and decades. But in the US, it's still relatively new. And so, Guido, I'll allow you to just, of course, jump in at any time. We've got a couple of slides later that get into some of the little more details of technology, and maybe in a couple of slides you can take over here. But fundamentally, you know, multiple units, and specifically diesel multiple units, offer a big savings just in terms of, compared to traditional equipment, you know, locomotive haul equipment, in terms of weight. And so you have a tremendous amount of weight savings here. You know, if you've got depending upon the configuration, if you've got a local haul train set with 2 coaches, you're in the 270 to 300 ton range. And a married pair DMU is, you know, it can be almost a third of that at 100 tons. So if you're saving 150 to 170 tons, obviously that means less fuel is used, so you have less costs, lower impact to the infrastructure, to the rails, to the switches, to the points in the system, and just generally better performance of the vehicles, faster acceleration, quicker braking, all those kinds of things. And so just a quick upfront comparison about, again, this is kind of just diesel specific, but in general, the tremendous amount of savings in weight that trickles through the other areas of running a system. And if you kind of generalize this, you know, in terms of multiple unit, in addition to the weight, there's distributed power. We'll talk about that in a minute. So again, this is not one locomotive just powering itself, pulling or pushing trains. The entire train is actually considered a unit, and you've got the power distributed in that train set, which has lots of advantages. One of them, which is that it's a very redundant system. So if you have a failure in a power a traction converter or a traction motor, you've got another set that can take over, and so the train is not going to be disabled. And so with that, you've got other elements here. So high availability and reliability. So, you know, the European market sees these very high availability, so upwards of 99%. Westbahn in Austria, we're operating bi-levels there there's actually 0 spares being used by the customer with a very high availability, which kind of gets into the notion too that is very European, but we're starting to see it embraced more here too, is that instead of having a lot of peaks and valleys in your maintenance approach and overhauls, you really try to have smaller, more consistent touches on these trains. So 4 hours a night, really working your way through different systems in terms of preventative maintenance and even some of the overhauls. And that way you can, owners are able to kind of keep a very consistent, known amount of maintenance and associated dollars that they have to spend on those types of things. Rick alluded to this earlier, but for our equipment, there's no longer a waiver that's needed with the Federal Railroad Administration. These vehicles now, before January of 2019, a waiver was required, but now with the alternative vehicle technology, which is now part of the CFR, customers can order these multiple units, and you don't actually have to go through the waiver process, which can be very cumbersome, which also kind of ties into the Rick, your number 3 goal there with class 1s, this making business sense to them. And so this equipment that we've been talking about really is consistent with class 1s and can operate on their in their territory with no other issues and no other modifications that need to be made to the vehicle. So we believe it's very consistent with some of the goals that you've outlined up front as part of the, you know, the high-speed rail kind of overall approach, if you will. And then a little bit later, we can talk more about the multiple propulsion options, and I'll let Guido chime in there as well. Actually, Guido, if you're still with us, right? Do you want to talk through some of the advantages and just the overall approach about multiple units with things like the bogie configuration?
I'm absolutely happy to do that.
Thank you.
But please, since I have to apologize, I joined a little bit late, and it looks like we have a separate panel than from what I can see as the permanent participants here in the call. So it looks like we are 3 people, but then I see there's a lot of panelists, so I'm a bit confused how many people we have in here, and how familiar are you guys with passenger rail technology in this case? So maybe Rick is the only person I see. I mean, my screen is a little bit distributed here. So
Yeah, so we have, all told, there are 72 people, including you, Matt, and I. And then for some reason, you guys are signed in 3 times for 2 people. But so let's call it 69 viewers.
okay, so that's pretty precise. All right. Well, I'm always glad when we count double, and you see that leads me to the Jacobs trailer bogie or truck. The thing is, the EMUs that we are building are typically based on shorter car types that share one truck, and that is this technology of what we call the Jacob trailer bogie or truck, which you see in the center here in that picture. The thing is, you basically see the accommodation for the air suspension. So they share it, and that allows that also triggers that these trains are always like a fixed formation. So you cannot detach them easily. Let me put it this way: you can do for maintenance purposes, but you cannot just detach for coupling. So that means typically these consists are smaller. So here we have already one of the larger ones, which is a 4-car consist. And we have traditional trucks at the end. They are motorized and they have electrical traction motors. Okay, and the whole origin of that train is basically an electric train. I don't know, Matt, do you have that in the next slide then, that we can see all the different versions of the Flirt family?
It is a little bit later. I think I've got an AVT slide, the next one, but it is a little
Okay.
bit later.
So then let's stick to this one here. What that means here, we have a 4-car consist based on an electrical train, but as we have potentially no catenary, we need to generate the energy ourselves, which happens in that center car, which is called power pack. And in that power pack, we accommodate, in the applications we have running in the US so far, we accommodate diesel gensets between 2 up to 4 diesel gensets, and that is pretty much related to the let's say to the performance profile that is needed from the train. So each genset has roughly 500 kilowatts. So in maximum we are like short of 2 megawatts for such a train, which gives it quite a decent performance. Passengers can go throughout the train, whereas in the power pack you can go through, but it's not meant to that passengers remain in there. But it's generally possible, but it's not ADA compliant in that area. These trains you see at the end, they have couplers that we can couple them to multiple operation of multiple units, and that means we could think of having like 8, the equivalent of 8 cars, 8 passenger cars for some peak operations. And then during the day, you might think of operating those as basically the smaller units for the non-peak operation. So that gives the operations a high level of flexibility. The coupling is within 1.5 minutes or something, and it goes fully automatic. So you don't need extra staff to do the coupling. The operator, the driver, they can do that automatically. And of course, that gives really a big flexibility to respond to different loadings during the day. Is there a question or something highlighted there? I might just open that. Yeah. First, accelerates into when accessing. So let me see if I can answer that. Has Stadler had any discussion with Chicago Metro Rebound? That is more a question for you, Matt, to answer that.
Yeah, we certainly have. Maybe what we could do is work our way through the slides, and then I know, Rick, you were going to sort of moderate the questions, perhaps.
Okay,
So
we don't take them off. So that's fine. It makes it a little bit easier. So then here it is. I think Matt has alluded to the crash absorption technology and the alternative vehicle technology. So if we take off the covers and look at the car body skins here, that looks a little weird. What is behind that? The red and green boxes are basically crash modules and crash boxes, and they have different functionality. So the end of the red one you saw in one of the pictures, because well, in reality they are black. These are they have the anti-climber functionality, but they're also crash modules. So in a crash, in a case of a crash, we have different levels of engagement. So the first level is the coupler, which has also some energy absorption, and it's not shown in here in that picture. The second level is then the red level. So if basically the speed is higher for a collision, these will collapse and absorb energy, and you can rather easily exchange those to new ones. So there is no structural issue on the vehicle if those are engaged. The next level gets for already considers quite a heavy collision, which are the green areas, and then you can see the yellow part that still their task is to provide a survival space for the operator. So that is actually state-of-the-art crash absorption technology that has also proven, unfortunately, proven in real life. Yeah, so in one of the scenarios where there was a truck, a fully loaded truck on the tracks, and the train bumped into it with something like 60 miles an hour. Okay, you have those nice things. So here you see how those things engage, depending on the severity of the crash. And what you see, the comparison here is between calculation and real crash. The simulation and the real test showed a pretty good validation of the theoretical results. Matt, did you also have the milk powder thing here or not?
No, I left it at this just to sort of show that we have to take those finite element analysis models and then actually, like you said, validate in the field. So
yeah, that's our models have proven to be very very precise. So that is embedded in basically all our trains, the single level or the bi-level trains. So this kind of technology we have in general, and we have it definitely for all the flirts here, and you see the different configurations that we can build, and it ranges from let's say 110 to something like around 300 seats. It always depends on the interior configuration. We are flexible with regard to toilet modules. We are flexible with regard to multi-purpose areas or tip-up seats or whatever. So these things can be accommodated according to our customers. Well, that's what I was alluding to in the first run. So if you allow me to point you first at the third level, which says EMU, and this EMU is kind of the origin of the family of the flirt. You see it has a pantograph. We have an overhead catenary. It does not need the power pack car in the middle because we take the energy from the catenary, and the end trucks are motorized with three-phase AC motors. So I think I answered one of the questions that I glimpsed on in between. So and each of the traction motor is force ventilated in our cases and has 500 kilowatts of power. So we have 4 motorized axles. The speeds in the moment in the US is 79 miles per hour according to infrastructure speeds. Generally, the design speed for these trains is around 110 miles per hour, and in some exceptional cases even higher. But that of course only works with electrical propulsion. I mean, overhead catenary. So if we look at the first row, then we have the ones that we basically have here. We have the center car where we accommodate the diesel gensets, and we have up to 4 or maybe 5 passenger cars. We can also do a bit of a combination, a hybrid solution. That is also quite interesting and popular, and depending on the level of electrification of the lines, which are pretty low in the US, so therefore the bi-mode in that configuration is likely not very popular. And on top, we also have like versions where we put batteries. We could put batteries into the center car, have a combination with pantograph to charge en route. There we have one application in Germany currently running. Or as we also do for San Bernardino County, the hydrogen version. So again, that is what we see here. This is the combination with the diesel, and we could accommodate either batteries, or we also have a solution for the hydrogen version. So the good thing is with that kind of approach, even if you start with a proven technology like we have with the diesel gensets, as they are becoming less favorable with regard to emissions, you are not stuck with that technology, because we can convert it into a potentially diesel hybrid or purely batteries. But then, of course, we need to see what is the profile of the line, because batteries on the one hand, they are heavy. On the other hand, they are still limited with the amount of energy we can store there. So if you have like major gradients in the track work, then they are empty quickly. So that's physics at the moment. But it means it's a very future-proof concept. So Matt, you want me to move on to the bi-level here?
Yeah, I think we had a couple slides on the bi-level before we maybe just sort of open it up to questions or take any other input from the group.
Okay, cool. So the bi-level, what you see here is the CalTrain application, which is currently en route to the test track in Pueblo in Colorado for type testing phase. Here is still an animation or rendering what you see here. Here we are talking a bi-level fully electric train with overhead catenary and high motorization, and it's really a rocket, that thing. And we have 8 megawatt power in there. We have in a 7-car consist, we have high acceleration. We have 110 miles per hour top speed. I think that is also not just design, there's operational speed. And that is quite an impressive vehicle, as most of you might be used to having long bi-level coach arrangements hauled by a huge diesel locomotive, and then this accelerates about with one third of the acceleration than this train here. So this is like for commuter application, this is fantastic, because you have fast acceleration, you have recuperation when braking, so all electrodynamic braking, and you have really good acceleration and deceleration values. And if you have so many axles motorized, as in the CalTrain case, you hardly need brakes that squeal and have other emissions when braking, because that all happens electrodynamically with the traction motors. So it's kind of highly wear friendly. Few specialities of that train is, for example, we have one coach where the whole lower level is made for bicycles. Yes, it's fully ADA compliant, but of course, to get from one level to the other, you need a wheelchair lift. We have ADA compatible toilets. And in this specific case here, we have doors on 2 levels so that we can accommodate 2 different platform heights. And that you see in the bubble, the upper left.
And let me chime in, Guido, really quickly, because this group would be certainly interested to hear more about that, because these 2 sets of doors, the upper set is designed to be compatible with the California high-speed rail system. And so that's the reason that they're actually kind of a unique height. It's 50½ inches tall, so they're not 48. Kind of unique to California. Since that system is not anticipated to come online, in the near term, we've actually blocked these doors and given the customer more seats in that area. And so eventually these doors will be utilized, but currently it'll be probably several years, I'll just say, before those doors would actually be used. But they are designed to be compatible with the platforms that will for high-speed rail in California.
Okay. Apart from that, the technology is the same with the double-skinned aluminum extrusion profiles, and well, you see like a traction motor there on the right lower side. So I think we can move on.
I think that was one of our last slides. This one's kind of a catch-all, going back to just the advantages as we see them, and just the general attributes of multiple unit trains, like Guido talked about in terms of the propulsion perspective, and we talked about some of the weight savings and distributed power components of these. And so, Rick, that more or less concludes what we had for the group, but we're happy to engage with any particular questions, or if you wanted to we can turn it back to you if you like.
Rick, you're on mute.
You're on mute, yeah.
Yeah, so yes, that was excellent. Thank you. And I have a question, and then I'll ask you some of the questions that came up.
Sure.
On the low floor for the CalTrain, what is the height of the floor? Because it seems to say it's 8 inches, but I thought it would be at least a small step up from an 8-inch platform.
It is. There is
Right.
a small step up from the platform, but not a lot. And that's why we also have that gap fill. I would need to look it up if we are like 12 or 15, but I can look that up. It's not. It's quite low actually.
Okay. I don't think it's physically possible, but if you could somehow have a train that had level boarding at 8 inches and level boarding at 48/50, that you could wheel a wheelchair through the whole thing, then we'd be set, right?
Well, we kind of manage the boarding, but the moving in the train then gets difficult, because the 48 or 50 is like on the intermediate level.
I had my architect's son, design the ramp and realized it's longer than the car. So.
Well, this actually is a little bit of an inset picture, kind of hard to see here, but on the CalTrain vehicle, to some degree, that's designed in there. This is actually a wheelchair lift that takes you between the lower level and the intermediate level.
Okay.
Yeah. So eventually, and these again, I believe the customer doesn't need them right away, so they're essentially being mothballed, but there is functionality to get as an ADA patron between those levels.
Okay. Excellent. So we answered the question about AC track motors. The answer is yes. Right? I don't know if you can answer Bill's question. Have you had discussions with Metra or another agency in the Midwest?
We have, absolutely we have. We've been talking with Metra for several years. We've also been active with the Northern Indiana Commuter Transportation District. Of course, they connect and they run on the Metra system from South Bend into Chicago, and so we think there's a fit. I mean, for this particular KISS model, of course, on the electrified networks of Metra, and then of course NICTI has that network as well. Guido can expand on this, but as of right now, The bi-level that's, I think, still on the screen, that's only available as an EMU. And we certainly have been talking as a company to develop some different propulsion ideas for that particular train set, because of course in Chicago, they're mostly a push-pull agency with some exceptions. But there's some evolution in our product portfolio, hopefully forthcoming.
Excellent. And then my personal opinion is we've got a couple of lines. One might be the Rock Island, certainly on the suburban line, but I'm highly confident that the UP North line would be an excellent place for high frequency service with the flirts. And I continue to say that out loud. I don't know if Metra has taken it to heart.
Well, we love the way you think. We've done some modeling and approached Metra, and for the especially the lower volume routes, it's a great fit for our single level flirt product. Absolutely.
Excellent. I don't understand the question, so I'll read it directly. Why in the AKKU do you have the batteries mounted on the roofs instead of in the power pack?
Yeah, somebody has studied our website there, so that is great because that's
Okay.
presented here. So really appreciate that, and that is a very good question. So the accu that will be operating in Germany, and the AKKU is just like in the German for accumulator, means we have there a special network that has overhead catenary, but so to speak interrupted. So some sections you need to cover with battery, and other sections there is catenary available. And that's why we actually did not really need an additional power pack. So, and we added the battery capacity on the roof to accommodate for those sections, which are something like 30 miles. But then the vehicle is capable of charging en route while in operation on the other sections of the network. And that's why we could actually save the weight to add another power pack. And actually that's quite this is a really, I like that solution a lot, because it's that hybrid between EMU and battery operated train.
Excellent. Do you know of any examples where flirts separate en route? So maybe they leave the center city in a unit of 2 and then they split to go on 2 different branches?
Well, it's actually quite common in Europe. I mean, the applications we have here are just small numbers in Texas, and I'm not sure if we have that with the GTW, Matt. Do you know if we operate like that, so that we couple and then detach, and every train forks off into another direction?
Yeah, it doesn't operate currently like that here, but it certainly could, to your point. Absolutely.
It could very well. We really have that in Europe a lot. As I said, the coupling is fully automatic. You don't need additional staff. It takes about a minute to couple. The operator has like a push button or a certain position with the master controller that you cannot go over a certain speed for coupling mode. And these couplers engage automatically, and then you can meet and go. This is even done in like say winter operations and stuff. So normally it's quite reliable. So yes.
Excellent. I was 2 trips ago, I was trying to catch a train from downtown Munich to the airport in Munich and got on the wrong section.
Yeah, that's the pitfall of that. So maybe they didn't properly operate the PIS system there.
And suddenly I'm like, wait, I'm too far out in the country. On the flirt for North America, does the operator wear a seatbelt or some sort of shoulder harness or something?
No, it's not needed. And I see you're talking about like because of glass and stuff. No, it's all laminated glass and stuff. So that's all safety stuff. It's partly bulletproof, or at least like I mean, there are certain tests that need to be complied with if somebody throws a stone or something in there. So that's all covered. It's pretty safe.
You know what I should have done? Gita was alluding to this. We have a video of this where it was a milk truck in I don't know if it was in Switzerland or Germany, but it got caught on the tracks, or it stopped. The operator of the milk truck, a powdered milk truck, got confused and didn't know where he was supposed to go. Got out of the vehicle, and this is on it's basically a security video. And then a GTW comes in, going about 60 miles an hour, and was, I'm sure, in full braking when the operator saw what was happening. Hit the milk truck, and the powder goes everywhere, and there was no derailment. And then you think, oh my goodness, what happened to the operator? But the subsequent picture showed, just like Guido said, the glass didn't shatter; it cracked, but it was still one unit. And then the operator was unharmed, and there were a couple of minor injuries on the train because somebody hit their head up on the side of the wall, I think. But there were no injuries, and so really it just absorbs the energies. The entire methodology with these trains is that even when you hit something like a truck, that you can have people just walk away from it.
So kind of like the egg crate is designed to protect the eggs. Right?
Yeah, exactly.
So it looks like one of these would be about 3 cars. If the 4-car configuration of a flirt would probably be about 3 standard coaches. Do you have a guesstimate of what the acquisition cost would be for one 4-section flirt versus a locomotive and 2 coaches?
Well, what I can tell you, yeah, I mean, sort of the and these are certainly obtainable by anybody. So the DART trains for the Silver Line, so the option price with those for a 4-car, and then of course the power pack, they're generally between $13 and $14 million for a 4-car train, and each car, I guess, holds about 60 people. And so on a 4-car train, again, depending upon if you want to have restrooms and so forth, 4-car flirt can hold about 240 people seated, that is.
Okay. But you don't know what a standard coach and locomotive set would cost for about that size?
Oh, for comparison purposes, that's a good question. Okay. A locomotive like that's going to probably run 7 or 8 million. I don't know what the bi-levels run actually. Yeah, it's going to be more money, I'll just say.
That's good enough. That's good enough.
Right.
Let me look through to see what else come in to see if there's I saw one that I wanted to make sure we got. Oh, here's an important one. The CN is saying that a standard Amtrak train is not properly shunning the grade crossings. Have there been any issues with the flirts?
Yeah, it is a little bit of an issue. I mean, essentially because it's lower weight, sometimes unless if the rail is not in great shape or hasn't been, cleaned properly or maintained properly, sometimes that will be an issue. So the operators that we work with, the owners in Denton County, have had to pay, especially with, during COVID, with lesser people riding the train, so the weights are even reduced further. They've had to pay a little more attention to the condition of the rail, and so I think that's probably what this person is writing in about. So that can be an issue, but with proper maintenance of the rail, we don't really see it being a big issue.
Okay. So Bill is asking, are there hydrogen powered units in service today in revenue service in the world?
No. The first one will be in 2023 in San Bernardino on this continent. I mean,
Okay.
hydrogen powered trains from our competition, they are going into operation, I think, basically soon, or they have definitely a prototype. It's Alstom. They're working on that, but nowhere in big scale. Just so far, single trains.
Okay. And then what is the top speed and the range of the battery powered?
The same.
Same. Okay.
I mean, 79 or something should be good. Problem is that speed goes in with the square. So if we want to go much higher, then energy consumption goes up pretty much.
Okay. And there's a question about, MBTA is talking about going to a regional rail type of model instead of commuter rail. And so Tom is asking how, if you guys are aware of that project, I guess, and if this would be, if the CalTrain type service trains would be good for that service.
Absolutely, right, Guido? That's one we've had
Our
on
favorite.
our radar. Yeah, we've actually had MBT has been out to our facility a couple of times, and they want to do a pilot. We think, as many of you know, their corridor is well, their lines are generally non-electrified, but one of their lines down to Providence actually is in the Northeast corridor, so it has overhead catenary at 25 kV, so the same system that the KISS will operate in, the CalTrain KISS. And so we've been talking with them and their consultants about running some kind of pilot program. They've got real ambitions to at some point electrify and modernize their entire network, and they've got a very large network. I think 8 different lines, and I think close to 1,000 cars in their portfolio of rolling stock. And so that's, I think, a longer endeavor, but I think they're wanting to kind of spend a lot of time to plan it right. And of course, nothing speaks louder than putting something in service. And for the most part, the CalTrain vehicle would be a good fit for them.
And then can you compare, I'll just read it. Can you contrast Jacob's bogies with the Talgo's style of independent wheels?
I think that goes to me, Matt.
Absolutely.
Well, the Talgo pattern is a very, very particular one, actually quite a highly interesting and sophisticated one, because what that has is basically single axle and a U-shaped frame that is standing upright. And the whole train is basically hung into that. And so it's a passive tilting system. So and that is something super smart and also proven for very high speeds. They have, of course, very short cars, because with one axle you cannot accommodate so much of weight. It is also a fixed formation, so that because each car needs the other car to basically balance the other end. So there is the commonality is that they basically cars share some truck basically. But that's all about the commonality, because the Jacobs bogies are like normal flat or H-shaped frame of welded design, where we have 2 axles, 2 pivoting points, and both car bodies sit on that and share that. And I have glimpsed on the next question, and that fits pretty well there, these are normally not supposed to be separated. So the train consist stays as it is. So they are not separated. It's not like adding cars or taking out cars. So if you have an issue in maintenance that you need, for whatever reason, need to separate it, can happen. Well, then you need an auxiliary truck to balance the load for the other one.
Okay. Harry Wong has this interesting question. So basically, U.S. trains are designed for minimum maintenance. I'm sorry, I don't know how to answer if you ask the question beyond that. But how do you get to the point where the culture is you're doing preventative maintenance as opposed to just fixing things as they break?
That is actually in our DNA. That if we do comparisons to how much maintenance is done actually compared to what we believe needs to be done, then I think these multiple units can provide a very high level of reliability and availability. So we have these KISS trains operating without reserves in Austria at 99.9% availability, and where you only have a 4-hour slot to fix them at night. So that should give you an idea about reliability and availability of those trains as electrically operated, I must say, electrical trains. So I think our proposal to the market here is to reduce maintenance effort.
Okay. We're getting very close to the end. David Phillips has asked, I think what you're saying, David, is when the two sets are together, you've got a challenge with the people can't walk between the two sets. But I've seen this has become pretty standard practice in Europe. So can you talk about why that's okay to have the two sets completely separate?
Well, it's pretty much to what I said before. So I mean, unless you experience your personal experience, Rick, that the train really forks off and goes into another direction at some point, then normally it's no problem because you don't need to run through the whole train. I mean, if you have like 4 cars or 6, 7, I mean, they're pretty long already. That are very long trains, and or also on the flirts, if you have a 4-car train, I don't see the need, or passengers don't see the need to basically go from one end to the very end of the other train. I mean, that normally does not happen. So it's absolutely no issue.
I took a trip in Spain one time where for some reason the conductor only had one of the 2 restrooms open. He had 2 units together. So to use a restroom, you had to get out at the station, run around to the other train set, use the restroom, and then come back at the next station.
You must have had some really good experiences here. You come all with a special case.
It just goes to show that railroaders are railroaders wherever they are, right? Because there was no reason to close that restroom. He just didn't want to clean it or something.
Yeah, okay.
And then the last 2 questions, real quick. One, how high are the KISS trains? And then the CalTrain trains, how high are they? And then can you talk a little bit about the high-speed trains that are running through the tunnel in Switzerland?
Well, we are at 15 something.
It's 15, 10 and a half is what I remember.
Yeah, okay, 10 and a half.
They're really tall. The reason I love them so much is because they're so tall. I'm 6.5 feet tall, and I can stand in either level and not hit my head on the ceilings. But they're very tall for the envelope. So I believe it's plate F clearance, right, Guido?
Absolutely. So then a quick one on the Giruno train, the high-speed train, which goes like 150 miles per hour. And top speed is a 11-car consist, also as a fixed formation, also with Jacobs trucks. Some of them are motorized, some of them are not motorized. Also has like 6 megawatts installed power. It runs on different voltage and PTC systems, which makes it a little bit complicated because it covers various countries in Europe, from Germany, Switzerland to Italy. And it virtually goes through the Alps, through the tunnel, through the long tunnel. It's a beautiful train. It's a single deck train. It's ADA compatible to basically platform heights in Germany, Switzerland, and Italy. Yeah, I mean, it has rather short cars. Therefore, it has so many cars. I think it's a super attractive train. It's a good, I'd say it's a pretty reasonable train, because as I said before, energy consumption or speed goes into the calculation of energy consumption with a square. So if everybody dreams just of even higher speeds, you can do, but you need to provide the energy for potentially very low level of time saving at the end. But that is what the operators need to think about. So I think it's a beautiful train. We have recently, I think we got an order for additional ones. They are in continuous production. Have a certain level of pressure tightness because they go through the tunnel, and so passengers need to be comfortable. You don't want to feel it in your ears and stuff. So yes, and apart from that, they provide all the gimmicks for what is now standard in a way, like Wi-Fi on board and like receptacles and chargers and all those kind of things.
Excellent. Looking forward to writing those. So we've passed the hour. Thank you all for sticking with us. Thank you for speaking today. I really appreciate it. For those who are listening, our immediate issue is the California Assembly will be voting on whether to appropriate the final round of funding for high-speed rail in the Central Valley. We've got a petition underway asking them to do that, and stay tuned for more information on what's happening with that. So again, thank you guys for speaking. I really appreciate it, and we look forward to talking with you again in the future.
Happy to.
Sure.
Thank you, Rick, for the
Thanks for your
opportunity.
interest.